So I'm James Bonadonna. My partners are Michalec and Lamberto, and our project is implementing Dijkstra's algorithm in C, which requires making our own priority queue class as well as the Dijkstra's algorithm itself. So the first thing that we did as a group was to implement a priority queue class in C, which is this. And basically it has just the main function. So there's a create class function right here, which just allocates it, um, sets everything to null, and then returns the queue to be used. There's a push, which just you send in the important information to be put into a tile, which is a node, and then it creates the tile for you, and then just puts it into where it should be. So if it's empty, it makes it the head. If it's smaller than the head, it makes it the new head. And then it also just iterates through and just puts it in where it should be. Then there's a pop, which just makes the new head the next node in the queue, frees that tile, and then decrements the length of the queue. There's a top, which just returns the head. There's a clear, which just deallocates all of the memory in the queue. Then what we did to implement that was in the rule book. Oops, might want to have .c in there. In the rule book, it used to be just linear movement, which was here, which I just got rid of because these are passed by reference, so this does the pathfinding for it. It implements Dijkstra's, which is implemented just above because it's in C. And what this does is it just makes a maximum range, creates a grid based on that range, and then it iterates through that and just implements Dijkstra's algorithm with it. So like there's the costs, there's you pull the top node, you pop it. If it has been visited, you pop and you continue. If it hasn't, then you continue and you just pop off that node. Then this is the exit condition. When it reaches the end, that'll be true. And it'll get the current map location, make sure that it is not the pound sign, which indicates that it is not traversable. And then if that's true, then it just changes the variable and returns that, which is then kicked out and implemented with the map. So the enemy moves that way. And these are just the if statements that ensure that the cost is less and that the location is traversable and has not already been traversed. And that's pretty much what we have so far. When you run hag, which is the code, the enemies follow you with Dijkstra's algorithm. And the problem before was it was easy to corner them. So if I were to do something like this, they wouldn't follow, but now they do. And so it works a lot better than the linear does. And really the only way to get rid of them is to kill them. And what we have yet to implement, we're pretty much done. We as a group spent a lot of time in the past few days just trying to get it done and out of the way. I'm not sure. We can. There's probably going to be a little bit more touching up, making it prettier, making it run better. But for the most part, like the groundwork is done at this point.